So from the last table, we discovered that the stone moved from S1, like I told you, to X1. So since it has moved to X1, what comes here, like I remember I told you, X1 is represented as advances. So what happens here is this becomes advances, this becomes X1, and then to get our new first row, because the pivot row was the first row from the last table. This was our pivot row. So the formula for getting the pivot row is you divide everything that was on the pivot row by the pivot coefficient. And our pivot coefficient in the last table was X1, right? So that was, yeah, it was X1. That was 2.5. If you go back to the last table, you see that the intersection between the column and the row was 2.5. So we have 2.5 here. So we have 2.5. Let's wipe this off so that it doesn't get confusing. So we have 2.5, 0, 1 minus 0.5, 0, and then we have our 5 here from there, all divided by 2.5. So 2.5 divided by 5, what does it give us? I'll be 5 divided by 2.5, my bad. So we have 2 here. So we have, let's just write it out here. We have 2. This is 1, 0. And then this divided by this gives us 0. So we plug this into the table direct. So we have 2, 1, 0, 0.4, minus 0.2, and then 0. And then for the second one, we know that the formula from the last one we did was the old second row minus whatever the coefficient was, multiplied by, now it's new first row, that is our pivot row, so multiplied by the new first row. So what we're going to have is, formula for this last table is going to be, do you get it? It's going to be the old second row minus the coefficient on the second row was what? 0.5, right? So minus 0.5 multiplied by, that's this one, because it was on the column, multiplied by the new first row. Now I know the question is, why is it new first row? It's new first row because this was our pivot column, pivot row from the last table. Whatever your pivot row is in the last table is what you use as your new row that you're using to multiply by. For the first one, the pivot row was the second row, so that's why we multiplied everything by the second row, new second row. But this one, our pivot row is the first row, so we are multiplying it by the new first row. Okay. Are we clear now? Yeah. So that it doesn't confuse anyone. So our old second row was given us 0.5 from here. It's giving us, 4. Let's start from the value 4, 0.5, 1, 0, 0.5, 0. And minus 0.5 multiplied by all of this gives us, the new first row was giving us 2, 1, 0, 0.4, minus 0.2, and 0. So if you multiply everything by 0.5, you have 0.5 times 2, that should be 1. That's 1. So what we have here is 1. Oh, yes, minus 1. No, just put it in brackets so that everybody knows. Minus 1, 0.5, 0, 0.5 times 0.4. That's 0.2. And then we have our 0 here. Are we good? So we have our triangle, X, the square, the circle, the rhombus, and the good. In other ways, you can do it that way. So this gives us our triangle. This is our triangle, our X, our square, and the good. So 4 minus 1 gives us 3. 0.5 minus 0.5 gives us 0. 1 minus 0 gives us 1. And 0 plus 0 gives me 0. So what we did is the triangle with the triangles, X with X, square with square, circle with circle, rhombus with rhombus, and then the good with the good. So we did it for the last row too. So for the third row, what we're going to do is, the formula like we all know is the old third row minus, now here you notice that we have a minus on the former pivot column. This was our former pivot column, right? So this is a minus, so it becomes minus 1.5 multiplied by the new first row. And the reason why we're using the new first row is because our first row here is the pivot column. In the former table, it was the first row. In the first table, the pivot row was the second row. So we're using the second row as the new first row, as the new second row in the last one. So for this third one, the pivot row in the last table was our first row, so it's multiplied by the new first row. So what we have is our old third row, which is giving us from here, from the back, we have 20, we have 1.5, minus 1.5, we have 0, we have 0, we have 2.5, and then we have 1. Then when this minus collides with minus, it becomes plus. So we have a plus sign here. So minus times minus becomes plus, and then we have our 1.5 into the new first row. The new first row is giving us 2, 1, 0. So we put our shapes. We have a triangle here, we have a square here, we have a circle, we have an X, we have a rhombus here, and then we have a good. Same thing we have here, triangle. No, we can't do this now. So we'll multiply out first. So 1.5 times 2 gives you what? Okay, that's a 3. Yep. Then we have a 1.5. Then we have a 0. And then we have a 0 here. So we put our shapes. We have our triangle. We have our square. We have our circle. We have our X. And then we have our grid. So, like I said, we match them. So 20 minus 3 gives, 20 plus 3 gives us 23. 1 minus 1 this gives us 0. That's this multiplied by this gives you all of this. Then you have your 20, which is this, your 1.5, your minus 1.5. This is minus 1.5, so that it doesn't look like a H5. And then we have a 0, we have 0, we have a 2.5, and then we have a 1. This is this, 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 and this. So this plus this gives you 23. Minus 1.5 and plus 1.5 gives you a 0. 0, 0 gives you a 0. Am I correct? And the X is 0 and 0.6 gives you a 0.6, a 1. So if you notice here, the index row is all positive. So there's no need to proceed. So you can interpret from here. So your interpretation from here states that if the bank... That's negative here? Okay. Once there's no more negative on this, it means that you're good to go. So since there's no more negative, no more negative sign, we interpret. So since there are no more negative signs here on this last row, right, then we can interpret now. So if we're interpreting, you now say that the bank should invest to maximize profit. The bank should invest 2 million on advances, 3 million on loans. You know all of these are in millions, right? We just put them as 2, 3 so that it becomes more presentable. So the bank should invest 2 million on advances, 3 million on loans to maximize the profit of 23 million. So the only way, putting all the constraints into play, all the constraints that were given to it, that's the 9 and 8 and all of that. If the bank uses all that, the bank should invest 2 million in advances, 3 million in loans to maximize the profit of 23 million at the end of the day. And then that's where the issue of shadow pricing comes in. Now we also notice that we have 0.6 because the question might pop up that, okay, what happens to the slacks and the DD and the SD? I mean, why did they all come in if they are not going to be useful? Yeah, that's where shadow pricing comes in. So it now states that from the first question, if you remember in the first question is indicated, you can see it on your screen from the question from the beginning of this lecture. You discover that it says that the total amount that was available for advances were 8 million, while that of loan was 9 million. Am I correct? Yeah. So it says that advances had, from the question, it says the bank had a total of 9 demand deposits and 8 service deposits total. So at the end of the day, if you want to check the shadow pricing, It's now saying that the shadow price for the DD is showing us, which is this S1 is representing DD, is 0.6, while the shadow price for the SD is 2.2. So what this means is, if we had 8, the total of 8 and 9 in the initial question, right? If you increase this by 1 million, from 8 million to 9 million, it means that the bank is going to get an extra 600,000. 0.6 is 600,000, you know now, in millions now. So 0.6 times 1 million is giving you 600,000. So it says that if you increase this 8 million from 8 million to 9 million, you will get an extra 600,000 on whatever you're getting. However, if you reduce it from 8 million to 7 million, you're going to lose 600,000. Likewise, if you increase this from 9 million to 10 million, you're going to get an extra 2.2 million. So if you notice it here, it's telling you to even invest more in loans, because loans here is giving you 3 million and advance is giving you 2 million. The same thing here. Advance here is giving you just 600,000 if you increase it by 1 unit, and then loan here is increasing by 2.2 million. Naturally, if you look at this, which one are you going to invest in the more? Loans or advances? Advances or loans? Loans. So it's more profitable to invest in loans based on shadow prices. So the shadow prices is just telling you that if the initial thing you started with, which was the constraint, if it reduces by 1 unit point, you are going to lose 600,000. If it increases by 1 unit point for advances, you're going to gain 600,000. Likewise, for loans, if you reduce it by 1 unit point to 8, you're going to lose 2.2 million. And if you increase it by 1, you're going to gain 2.2 million. So it's better to even reduce, if you're going to reduce anything, your advances than your loans, because your loans are going to make you lose more as compared to advances. So that wraps up the topic for linear programming, Simplex Table or Simplex Tableau, like I like to call it, under linear programming. Remember to subscribe to this channel, share the link for those that might have something new, because there are other methods of solving this, right? This might be a more cumbersome method, but it's more effective and more efficient because it tends to reduce chances of making mistakes. Like you already observed, we made a couple of slight mistakes, but we're able to discover them because the method is more vast and we can see everything. So remember to subscribe to this channel, Debugging Math, and share with friends and anybody that is interested. Remain blessed. Ladies and gentlemen, that wraps it up for linear programming.